Hello everyone, welcome to Mthobisi Mhlongo Mathematics and Physical Science YouTube channel. We're back again with the grade 10 Physical Science paper 2 June exam that was written in 2024. And question that we're focusing on is question 3. Now question 3 talks about states of matter in the kinetic molecular theory. And in this question links up to the experimental uh, phase changes or rates. Um, the experiment that we did, whereby we were melting ice and measuring the temperatures. So after doing all of that experiment, then a graph like this will then be plotted for phase changes. Now, let's get into the questions of today. In question 3, you're given a diagram below that shows the temperature changes of water when heated. Now we start with 3.1 where you have to define the term boiling point. Now definitions are very important because they have um, 2 marks. So in 3.1 you have to define boiling point. Now this is the temperature at which vapor pressure equals atmospheric pressure. So boiling point, the temperature to vapor pressure equals to atmospheric pressure. You get that from the exam guideline, and if you don't have the exam guideline, maybe from your educators, just send a comment, then we can simply add it to the description as well. All right, now write down the phase of water at stage A. Now we have to look at this graph. If you're moving, if you're looking at stage A, that is where this water is below 0 degrees Celsius all the way up to negative 30 degrees Celsius. And water below 0 is actually frozen ice. And frozen ice is the type of phase whereby water is a solid. So 3.2.1, we have water as a solid. And then 3.2.2, we're looking at C. So from A, excuse me, from A, there is a transition that takes place, which is B, whereby the temperature is not rising. And then after that, that is from 0 to 100. You know that water boils at 100, but then before it boils, what phase is the water in? The water will then be a liquid. And then you have in 3.3, write down the letter that represents the boiling point of water. Well, boiling point of water, I know this is taught from natural sciences 100. So where do we find the letter where the water is at 100? That is letter D. Now 3.4 then further asks, explain why the temperature remains constant at point B in terms of kinetic energy. So you have to explain and also incorporate the use of kinetic energy. Now, what is happening in point B? Remember I said there's a transition that is happening in terms of phases. Um, in point B, you can write that in point B, a phase change is occurring. So a phase change is occurring. With that being said, we're at the transition of moving from a solid to a liquid. So either way, you write it like this, or you explain it the way I'm saying it. And that phase is called the melting point. Now, when a phase change, so therefore, when a phase change occurs, the average kinetic energy, so the average kinetic energy will remain constant for that short period of time until every um, particle or molecule has undergone the phase change. Right, now let's look at 3.5. Now we have to name the phase change that takes place when atmospheric water cools down. So water then boils. After it boils, it becomes atmospheric gas. Now that is 3.5. And the gas then has to go back into becoming a liquid. You say it condenses, and that process is called condensation. Condensation. 3.6. Name the phase of matter in which atmospheric water would be after undergoing the phase change in question 3.5. So we're moving from a gas into a liquid. So the answer here would be liquid. Last question, 3.7, that says explain the changes in structure that atmospheric water vapor undergoes during cooling by referring to the kinetic molecular theory. Right. Sorry about that. Having a slight flu or cough that keeps disturbing me, but we're almost done. So let's see what happens. Now you heat up this water, it boils. After it boils, then it becomes a gas, and it's so excited. It's in excited state. Now, after 100, the kettle will stop. If you remove boiling water from a stove, it will stop. All of that gas, what happens to it? So the particles will start to lose energy. So particles, they will lose energy. As they lose energy, the particles will move slower because they were moving with a high kinetic energy. So the particles will move slower. And as they move slower, now they come closer together. They are going to form bigger molecules. And depending on where they are, if it's a kettle, if it's a beaker, they will form forces of attraction. So particles form forces of attraction. Last one, as they were in their excited state, they had a freedom of moving freely without any altercation. But now, as they are coming close together, there will be less space between them, which means the space between the particles will decrease. So the space between particles decreases. And that brings us to the end of question 3 and states of matter and kinetic molecular theory. So please like, share, and subscribe, and stay tuned for our next video. Thank you.